Welcome to a brand new series of events, Explore Lowlands. In Explore Lowlands, we explore new and fascinating technologies around the world. This is a collaboration with the global XR community, the community for everything around virtual, augmented and mixed reality and the Metaverse. I'm Raita van Rijswijk, Microsoft MVP Developer Technologies and Engineering Manager.
Hi, and I'm Saskia Groenewegen. I'm Technical Lead for Immersive Technologies at Ordina. I'm co-organizer of the global XR community and also Microsoft MVP for mixed reality. Today we have two very inspiring talks. First, we will spend an hour with Gabrielle of Microsoft and Katja of Nvidia, who will talk about navigating the world of AI infrastructure as data scientists. Followed by a trip across the Metaverse with Thomas from Microsoft. And after each talk, we will have 10 minutes of Q&A, so please ask your questions in the YouTube chat.
Thank you, Saskia. Please be mindful that all our events adhere to a code of conduct, which you can find on Lowlands.Events. So, without further ado, let's start with our first session. It's a special one where Gabriella and Katja will talk about how the world for data science has changed in the last decade and what this means for our aspiring data scientists, the educational system, and the hiring companies. They'll share some tips and tricks on AI for video analytics as well. Katja is a senior data scientist at Nvidia, and Gabrielle is an AI technical specialist at Microsoft. As a side project, she built an algorithm which helped cure a rare epileptic disease for her son. Super cool. I'm very much looking forward to this session. Ladies, when you're ready, please take it away.
Thank you so much, Raita. Hi, everyone. Very glad to be here together with Katja, close partner of Microsoft Nvidia, and we are going to talk a little bit today about kind of what we see in our daily professional lives, and also how it has been, kind of grown a little bit more complicated for data scientists. So today we're going to talk about navigating the world of AI infrastructure. This is a topic that we see growing by the day more and more, and also a lot of specialists within the field. But before getting to that, let's start a little bit where we're originating from. The data scientists originally in the very, very beginning were most of all actually not even called data scientists, but often more than So until 2012, artificial intelligence was mainly a research domain with a lot of hopes and dreams of what it could become, but wasn't there yet for many different types of hurdles. But what is very interesting is that you see a significant shift happening since 2012 in the area of data science. Back then, and I am actually coming from that world also, it was pretty straightforward, right? If you would have a data science project, it was more on a statistical analysis, where you would go into the lab, you would run your script, would go get some coffee because you had to wait quite some time for the script to be ready and to be finished for all the calculations. And then when you were coming back, you either were successful because you got your results, or you had to rerun because you had to debug anything, or in some cases also saying, well, I need to change some of the parameters. However, what then happened actually is that you saw certain competitions happening in the field of computer vision. And this was huge. Back then, when I was in university, I know this was actually also happening. You would have these PhD students that would really focus on, hey, can we predict that this is actually a ship and not something else? And if you think about it today, it's so easy to think, well, that's just a very easy trick. So if we look at kind of where we are landing there, we see that we're also going a little bit more further into that whole space. So artificial intelligence, for a lot of people, it's a broad discipline, right? It's something that was actually coined in 1956 and was really kind of a research-related topic. We got into machine learning, which was very related to still the statistical analysis. And then you saw actually deep learning starting to appear slowly into the research area, so such as with the computer vision and the many kind of competitions that were happening around Pascal, for example, the data set. But it took a major splurge actually in 2017. The scale of models of that this AI compute powers is unlocking and growing. Part of this has to do also with the technology of how it has come to existence, right? Compute has always been a very difficult topic throughout the history of artificial intelligence. Compute was something that specifically for deep learning, but also machine learning, often required a lot of parallelization of compute. The breakthrough in human parity have created an accelerated AI innovation significantly since 2015, starting with ResNet. And ResNet was kind of this very important thing for the field. But you also saw that a lot of that human parity was then also being brought up in different types of topics, such as natural language processing, something that you can find back in, for example, GPT-3 from OpenAI. Also, another factor that was really, really critical for this is the explosion of data, right? Combined with that increased computing power, it has advanced AI significantly. But what about those data scientists and all these advances that have been made throughout these last 10, 15 years? Well, let's start with that example. First, can I use your script? It started all with that. And then you would need to know what type of environments were used in the way that it could also be copied into the other example. And this is something that originates back, I think, to a lot of people from their research experience, and especially if you worked with MATLAB or with R. If your environment with the different versions of libraries were not matching with the one from, for example, your professor, per definition, you had to rewrite your code in order to match it with the environment of your professor or your peers. And this is something that we also see in data scientists. So you also started to learn more about more traditional computer science related topics. And with this also comes something additional, and that has to do with libraries. Because of the explosion of AI, we also saw a lot of libraries come into existence, such as OpenCV, that have made a significant progress inside the artificial intelligence community, but we're also requiring other type of skills than the traditional researcher. And then also something that is actually close to my heart, DevOps. Very early on when I started in Microsoft, I actually joined very specifically for this topic. And it had to do with the following. Before working at Microsoft, I worked for a consulting company where I would also create certain models for banks. And I had this amazing model that could predict whether there was terrorism financing going on, yes or no. And I kind of how young I was, I went to the IT department and said, well, if you implement this model into the system, then your bankers can automatically see it almost near real time when this is happening. And they had to laugh because they didn't really know if they had to take me serious or I was just joking. And that had to do with the fact that I didn't understand what it took in order to get a model into production. And that has to do with a lot of additional components. So suddenly data scientists had to learn a lot more than the traditional modeling of a model, right? You had to learn a little bit about DevOps. You had to learn about how to set up your environments, how to make sure that all the versions were matching to that model outcome. And then also additionally, you had to put it in containers, which was also not something traditional for a lot of data scientists. You had to also include security, and then you also had to do something that is related to DevOps, which is CI/CD. So suddenly you were, as a data scientist, focused on a lot of additional things aside from only model creation. And that is very tough, because if you think about where a lot of the data scientists were originating from, which is research, they didn't have a lot of traditional backgrounds in computer science. Often, just like me, I was trained as a computational neuroscientist. I didn't do a lot around software engineering. But it's not that, only that, right? Because what we now see in terms of a trend is also an additional field that becomes very important. And that has to do specifically with that deep learning, highly parallelizing all those workloads from a hardware perspective. Hardware, and in specifically high performance computing with GPUs or silicon, so GPU stands for graphical processing units, brings a whole new array of topics to know about that, in order to have your setup set. Because suddenly you are using compute for multiple VMs and you need to interconnect them, and you need to know how to see how your GPUs are performing. All kinds of topics that are traditionally belong to HPC engineers and not necessarily data scientists, but very critical to the workloads that a lot of these data scientists are currently or nowadays doing. And that has to do with the type of models that we're now creating. Think about, for example, GPT-3, or think about DALL-E, or think about the Megatron Turing models, or even computer vision. They all require a specific type of compute, namely GPUs or silicon. So what does hardware bring? So hardware has a lot of different additional components to think of. Think about InfiniBand, the type of VM that you're using, the VM image that you're using in order for you to create the libraries on top of your image of your base image, right? And then also additional distributed training. And distributed training is very critical to deep learning because it speeds up the process. Because what you're doing in essence with distributed training, and for that you also need the InfiniBand, the type of VM, and the VMI, is parallelizing all those VMs to do a small calculation of the total of that model. So if we're talking about GPUs specifically for AI, right, where we see kind of 6 different trends. It's about scale up and scale out. So meaning, am I using all the nodes within that VM, right, the different GPUs that are inside one VM? Or am I using multiple VMs and all the different GPUs in that array of VMs? And that has to do with interconnect. And that has to do really with InfiniBand and networking, and becomes very critical because in essence what it does, it communicates between the different VMs and allows to say, well, I'm done with my calculation, what's next? And if that communication is very slow, you will basically have certain VMs waiting for a different type of response. Additional, what we are also seeing is that GPUs require additional needs, also CUDA, so for the computational purposes. And this is a little bit different from using CPUs. But also understanding how to set up CUDA versions with the libraries that you're using, such as with OpenCV, requires some additional knowledge. So what we're seeing is that when we're building complex ML models, it requires an AI-first infrastructure that is really set for an enterprise setting, where aside from the traditional things such security, DevOps, and many of the other topics, now also requires the knowledge of what we call HPC. But those are really, really critical when we're talking about making computer vision work and work efficiently. So we have on the left side, we have GPU architectures, right? It allows us to heavily parallelize the workloads that we want to train or inference. It's really optimized focus, so making sure it speeds up the process. And it has very specific purpose-built design, because for deep learning, you need a lot of different GPUs that communicate in the right way to each other. And then also you want to be able to scale out and speed your workloads. And then on the right side, you have model development. So more the traditional sides of what a data scientist was originally doing. Data-based models, it was really kind of focused on what data do I have, what data do I bring in, which parameters am I using, and how can I use them in the most efficient way possible. So if we're talking about this, you want to have something that is called an AI-first infrastructure. And that AI-first infrastructure takes into consideration all the traditional HPC and enterprise settings from more software design, but also combines that with the traditional world of data scientists. And that takes away a lot of the difficulties and issues that traditionally a data scientist would find because they simply haven't been trained on this. It's a mix of traditional GPU architectures with the automated model development and deployment of the data science platform. And an AI-first infrastructure allows for complex models training and inferencing and enables real-time responsiveness from the cloud or the edge, and augments performance with deep insights and empowers more strategic decisions making a favorable outcome. So within Azure, we have something that is called an Azure Machine Learning Platform. And this is specifically designed as that AI-first infrastructure. It allows data scientists to work in the same ways, in the same fashion as they used to, but to do also these additional components, such as what you would find in software engineering and with HPC, such as GPUs. And the nice thing is that it provides a lot of key components in there that would allow for these very complex models to be built without the necessity of learning all the different aspects of the world outside traditional data science. Parts of this also has to do with Nvidia. And we have a close partnership with Nvidia to also work on that AI-first infrastructure. A lot of people know Nvidia also from the GPUs, so from the hardware, but there's also a lot of additional components that make the life of a data science a lot easier. And those have been integrated also into the Azure Machine Learning Platform. A good example of this, and Katja will talk about this later, is actually about computer vision or intelligent video analytics, because this is one of those workloads that we see growing tremendously, and has also the requirement of that GPU architecture with that enterprise setting from a software traditional perspective, while integrating that traditional data science world. And Katja will tell a little bit more about this in 2 minutes. To give you an example, to kind of think about, autonomous driving really requires a lot of that AI-first infrastructure, because it needs a lot of GPUs, it needs to have the enterprise setting for example, security, but it also has the traditional data science in there. And I'm now handing it over to Katja to elaborate a little bit more on this topic.
Thank you so much, Gabrielle. Let me share my screen now. Could you confirm that you see my screen?
We see your screen. No, we don't see your screen yet.
See it yet. Okay. Do you see my screen now?
Yes.
Yes, perfect. All right, thank you, Gabi, and I'm really happy to join you today in my talk. This is my part of the talk, and I'm going to talk about best practices for real-time intelligent video analytics. I'm really passionate about this topic, and I've been helping our partners and customers in deploying their AI models for video analytics while working at Nvidia. So let's dive in. And actually, the first question would be, why shall we actually care about intelligent video analytics? So we have many use cases for video analytics, and they range like for different industries, starting from traffic management, smart parking systems. In manufacturing, video analytics is used for quality inspection, for packaging control. In retail, cameras and video analytics can be very helpful for stock prediction, restocking the shelves, or for solutions like autonomous shopping, where a person comes into a store, grabs something from the shelf, and walks out and getting charged automatically. In healthcare, intelligent video analytics helps a lot with such cases as, for example, assisting during surgery. Very often, surgical instruments are actually left in human body, and to prevent this happening, cameras and video analytics can help. It is used in the factories, like for example, to see that the factory workers are wearing protective gear or helmets, or that large machines are not colliding with the factory workers. In the public spaces, intelligent video analytics can be used, first of all, for safety, to see that there is no fight. Or recently during COVID, there were many systems have been developed to see that people are wearing protective masks. In warehouses, you can think about robots. So AI and video analytics is used to actually make robots autonomous and navigate through the factory and warehouse environments. And finally, in transportation hubs like railway stations or airports, you can think of use cases for safety, for control. So there are many other use cases, and you can think of any further use cases in any industry. So the opportunities are really large here. And however, it's also important to mention that intelligent video analytics is rather challenging to work on. So first of all, you need to make sure that your AI models are of good quality and good accuracy. So you need to collect lots of data. You need to verify that your model works correctly. And once you've done it, you need to test it in the real environment. So now imagine you have achieved a model of a good accuracy. It works perfectly fine. The second thing you need to take care of is the model's throughput and latency. For some really critical applications, like for example, autonomous driving, you cannot wait for minutes to get your inference result back. So you want your model to react immediately. So for that, achieving real-time performance is really very important. And finally, the next question which comes, how do I actually deploy my model at scale? So as Gabrielle has mentioned, that developing a model is one thing, but then deploying the model and making sure that the model runs everywhere in the world on all kinds of different hardware, this is another challenge. And at Nvidia, we actually aim at supporting all our customers and partners and solving their challenges by providing the so-called end-to-end workflow for AI. And I'd like to share with you some, well, how this workflow works, and actually what are the tips and tricks for getting the best out of your video analytics deployment. The first tip and trick you can apply to make your model run have a faster throughput and lower latency is called quantization. So quantization is basically a technique which allows you to reduce bits per weight, meaning that instead of using and deploying the model in floating point 32, you actually map your model to lower precision. And at first we were using floating point 16 and the performance was already much better than with the models of floating point 32. However, then researchers thought even further and said, well, maybe we can even reduce it even further to integer 8. And it's a little bit trickier than floating point 16, because in the case of floating point 16, you just basically round up the floating numbers and it still works well. However, you cannot just remove everything up to the integer bit, because you will lose a lot of accuracy. And in order to avoid losing accuracy, what you can do is to provide this mapping from floating point 32 to integer 8, to the interval from minus 127 to 127. In order to do that, what you need to do is you take your model and you find these intervals from the maximum to the minimum value in your model weights, and you map those to this integer interval. And there are two ways to do this. So first way, you can do the so-called post-training quantization, or another way to say calibration, where you take an additional data set and you run your model through this data set in order to find this maximum and minimum values. Another way to do this is to apply the so-called quantization-aware training. And quantization-aware training means that you model actually the quantization error from weights and tensors during the training. So you have an additional loss for your quantization. And then on the outcome of your training, you get your trained model and this calibration file, which you can use then further in the deployment in order to make your model smaller in size and faster in throughput. So it's a very helpful technique. It is available in popular frameworks like TensorFlow and PyTorch. And we also have it in our Tower toolkit, which I will mention a bit later. The second useful technique is called network pruning. And network pruning is basically reducing the number of weights. So the idea behind is that you take a neural network and you rank all its neurons based on the influence to the final outcome of the network. If you find some sort of lazy neuron, you can eliminate it based on some threshold from your network. By doing that, you remove that neuron, you remove all the connections between this neuron, and it makes your network work faster. And on the image I'm showing you here, you can see some sort of a perceptron type models, and it's a simplification. And the pruning actually can also work on the convolutional level. And usually this process leads to some accuracy loss. However, there is a way to regain this accuracy by retraining your model for a couple of extra epochs. And this usually leads to a really good reduction in model size. But also, as you're removing the connections, the model gets faster in throughput. So also highly recommend you the pruning technique. This is another technique which is called network graph optimizations. And well, you can do some sort of layer in tensor fusion. This requires, however, a little bit knowledge of a little bit lower level of CUDA programming, and for that you can basically do merging of these kernels, as you see on this slide I'm showing you. So you can actually recognize it's an inception network. And what we've done here is basically we merged the units like ReLU, bias, and one-to-one and 3-to-3 convolution. We did it horizontally and vertically by parsing the graph. Why do we do this? Why does it make sense to do it? Because, well, each of these kernels are super fast in execution on GPUs. However, calling these kernels is a costly operation. So it, like moving the data from kernel to kernel, it can be seen as a bottleneck in the model execution. So the fewer of these kernels we have, the faster your model gets in the execution. And this is done by parsing your graph and doing some graph optimizations. The whole mathematical structure of your network remains the same. It's just the way it's executed is being optimized. What you also can do is you can basically brute force your network on different devices. So it's not a secret, we have like many different GPUs of different generations, but also we have cloud GPUs, data center GPUs, embedded GPUs. They are all different. They have all different sizes, number of tensor cores. And your networks are also different. The number of layers, types of layers in the networks. You can have different batch size, different input dimensions, different filters, tensor layouts. And what's really also important that you can have different algorithmic implementations. There is a number of ways to implement a convolution, and they all can be executed differently on different hardware. So a way to do that is to make a network run on your target hardware and just go and pick different kernels which are better suited for this kind of hardware. By doing that, you can assure that you pick the right kernels which enable your model being executed in the fastest possible way. The next technique is called dynamic tensor memory upon inference, and it has been inspired from register allocation in compiling, which is the process of assigning a large number of target program variables onto a smaller number of registers. Applied to deep learning, what we do here is we combine the network tensors into regions, and a lifetime of such a region is, well, it's a section of a network execution time. After you have combined the tensors into regions, you assign these regions into blocks. And these regions assigned to a block, they have disjoint lifetimes. This technique also helps you to have faster throughput. Then we have multi-stream concurrent execution, and turns out that also all these kernels, they can be executed in the so-called concurrent fashion. By H2D, D2H, we understand the memory copy, or those of you who are familiar with CUDA programming know that it's host to device and device to host operation. And apparently, you can basically execute your kernel parts and these memory copies in the parallel fashion. And by doing that, you also compress the execution time, which leads to performance improvement. With that, I'd like to actually highlight all the NVIDIA products which can help you utilizing these techniques. All these products are free, and you can use those even for commercial deployment. And also, I'd like to start this part by citing our CEO, Jensen Huang, who likes to say that NVIDIA is not a GPU company, it's a platform company. And in fact, yes, many people know us as a GPU or gaming company. However, we actually have more software engineers than hardware engineers. And we do our best to make our products work and perform the best way on our hardware. So we would like to say that we are not developing hardware only, we are developing the whole platforms. And as I've already mentioned, we are striving at automating the whole end-to-end workflow. And this is, well, a very simplified version of how our end-to-end workflow looks like. And on the left-hand side, you can see the pre-trained model library. For that, we actually have created, well, we have collected and curated our own data sets, and we have trained the so-called purpose-built models, pre-trained models, which you can use also for free in your commercial setup. We host these models on the Nvidia GPU cloud, or NGC shortly, which is basically a repository of all free software, which I'm mentioning there. So go to the ngc.com and yeah, you will find all the software there. So we have pre-trained models for such use cases as people detection, vehicle detection. We have also models for natural language processing and automatic speech recognition, models for pose estimation in 2D and 3D, for license plate detection, and for face detection. You can take these models and you can use them to train your own model. So first of all, you can use these models out of the box, but you can also adapt them to your own use cases. Let's say you have a data set of people wearing masks, and you want to create a specific model to detect if there are people wearing masks or not. What you do then, you bring your own data set and you select one of our pre-trained models. And by the way, we have also state-of-the-art architectures available there too. And you can then train, adapt, and optimize your own model with our software tool called Tower Toolkit. So Tower stands for train, adapt, and optimize. Then once you have done this, you get your own model, which is production ready. And with that model, you go to your deployment platform. And by deployment platform, we can understand also all kinds of hardware with Nvidia GPUs available. And for that, we have also a list of software products which you can use, such as DeepStream, which I also mentioned in a while. We provide you with the whole development environment, and also we provide you with some open source turnkey applications, which you can find on GitHub. So this is the end-to-end AI development and deployment in the nutshell. So let's go and look through the components of this workflow. These are the models which I have mentioned, the pre-trained models for AI. And this is not the full list, because our engineers are working fast in addressing many use cases, and we constantly update this list. So here you can see the models, as I mentioned, for people detection, for gaze estimation, gesture classification. So these models, they have been optimized for high throughput by applying the techniques I have mentioned, like quantization and pruning. The accuracy is very high, so we like on average, we report over 80% accuracy for all these models. They are production ready, so as I said, you can download it and integrate in your application and use it as it is. But if you want to adjust it further and adapt to your own use case and your own data set, you can adapt them with our NVIDIA Tower Toolkit. So let's look a little bit closer at our Tower Toolkit. What is that? So Tower Toolkit is our software product, and it is used to train neural networks for vision AI and conversational AI. We are working on delivering a user interface to it soon, but now it works on Jupyter notebooks. So we provide a collection of Jupyter notebooks for different use cases, which you can download at the NGC. And we also include tools for data preparation and augmentation, of course, for training, and then for optimization, like pruning and quantization. Tower Toolkit supports quantization-aware training, so you can have your own model and the calibration data after the training. It works on the CUDA-X stack. So underneath it depends on NVIDIA Container Runtime, CUDA, cuDNN, and TensorRT. And for training platforms, you can use anything from workstation, DJX or certified workstations, or in the cloud. So it's 100% compatible with Azure, and it can run on Azure as well. And for inference, again, you're very flexible in, you can choose anything. By the way, the models trained with Tau are 100% compatible with our optimizing compiler TensorRT, and TensorRT includes all this tips and tricks for inference optimization, which I have mentioned. So it's really useful, and it helps with the whole end-to-end workflow. It supports multi-GPU training, and those of you who have tried training with multi-GPUs, you know that sometimes it's not that straightforward to understand how it works. But with Tau Toolkit, you basically just specify the GPUs you have and their index by including only this parameter you have here, and then it works as it is. It also supports automatic mixed precision training. And by automatic mixed precision training, we actually understand another technique, which is hardware associated. So it is there available from the Volta architecture, and it relies on the so-called tensor cores, specific tensor cores for deep learning training. And with this technique, what you can actually do is, instead of running all the intermediate convolution operations in floating point 32, you can actually switch to floating point 16. Then you can switch back to floating point 32 to do the optimization step, and you switch back to floating point 16 for the backpropagation process. By doing that, you can accelerate your training process, and accelerating training process means that you can iterate faster, you can try different hyperparameters more often, so you can run more experiments on the same hardware. And this also helps to reduce memory bandwidth, and meaning that you can also train larger models and use larger batches. So this is super useful, and it comes for free with your hardware. It is available in frameworks like TensorFlow and PyTorch. You just need a couple of lines of code in order to enable it there. In Tau, it's also available. You just basically specify the use amp parameter when starting the training, and you can benefit from your training speed up. What's more, that in addition to all these pre-trained models, we actually offer you a large collection of state-of-the-art models. And again, our engineers work very hard to extend this set, and there are new architectures coming all the time. So you can see that nowadays we support classification, detection, and segmentation. And this is only when it comes to vision. We also have the speech models, which I'm not covering here. And we support most of the popular backbones. All these networks, they have been pre-trained on the open image data set. And the good thing about this model is that there are no legal restrictions associated with this model. So they are also free for you to use in your own production. I've already mentioned the NVIDIA TensorRT, and NVIDIA TensorRT is our product, which is basically two things. The first one is the optimizer or optimizing compiler, and the second one is the runtime. So we offer an API which you can use to integrate your models and deploy using TensorRT, using your optimized TensorRT models. So as I mentioned, you can deploy Tau models with TensorRT as well. It is also compatible with frameworks like TensorFlow, PyTorch, MXNet, and most of the popular frameworks. You can actually export your model to ONX and optimize your ONX files using TensorRT as well. And all these techniques which I mentioned, like layer and tensor fusion, calibration, quantization, kernel auto-tuning, dynamic tensor memory, and multi-stream execution, they are implemented in TensorRT. You don't have to do anything there, so you don't even have to understand how they work. It's, of course, good for you to know. But with all this, with TensorRT, this all is hidden under the hood. So basically, you just execute it and you provide your model in ONX format. Or you can use direct integration of TensorRT in TensorFlow or PyTorch frameworks. This is also possible. And in the output, you have the model, which is highly optimized for your specific platform. One important thing to mention, though, is that while optimizing your model, it has to be performed on the target hardware. And this is associated with the step, with the kernel tuning step. Remember, I mentioned that we need to do the brute forcing in order to find which kernel works the best for the given hardware. So for that, this optimization step has to be performed on your target hardware. But the good news, it has to be performed only once, and then you can copy your created model to all the hardware of the same family. So how the process works. So in the first step, you optimize your model. You take your trained neural network, you import it in the TensorRT optimizer, and in the outcome, you get the so-called serialized engine. We can also call it plan or TRT file. There's a number of formats for that. And in addition to the model weights, it is actually the plan file stores the instructions to the executional environment, how to run this model on a given hardware. On the deployment phase, what you do is you take these optimized plans, you deserialize these engines, and then you deploy it in your environment. Furthermore, we have another software product which is called Triton Inference Server. And Triton Inference Server can be viewed as a standalone server. So if you have, for example, static images or text or basically any kind of model, you can deploy it there on any kind of hardware. It not only works on Nvidia hardware, but also on GPUs from our competitors. It also runs on CPUs, and it supports model of all possible formats, including TensorRT, PyTorch, TensorFlow, ONX, OpenVINO, Rapids, which is our own data science framework. And you can even implement your own custom backends in Python or C++. It has also two really nice optimization features. The first one is called dynamic batching, meaning that when serving your model, you can process each incoming, when talking about images, frames, not individually, but batching them like in a bigger batches. So instead of running the model a number of times, you execute it once, but with a bigger batch. And another optimization technique is concurrent model execution. You can actually use the same physical GPU, and relying on CUDA stream technology, you can you can do multiple inferences at the same time. It has also like nice features like utilization throughput and metrics. It has a load balancer and model scheduler. So really also a highly recommended tool for deployment of your any kind of AI models. And it's actually open source, and we host it on GitHub. So it's all transparent and you can get access to it. Finally, at last but not least, we have our DeepStream SDK. And DeepStream SDK is our software product for video analytics. And the idea behind is that we provide you with, a set of accelerated plugins which help accelerating the whole execution process for video analytics tasks. So DeepStream relies on accelerated plugins for decoding and encoding. You can run it with pre-trained models, so it has inference plugins. It has IoT messaging, and you can save your video streams to the file or send them to the server. So it also works with Azure, and there are nice blog articles about integrating it. This is a typical deep stream pipeline. So you have your image or video, and well, the frame goes through this whole pipeline, starting from capture and decoding. Then you do some pre-processing like scaling, dewarping. You do batching. Then you apply your real inference, and you can further apply technique. Well, algorithms like tracking, for example, for person tracking, analytics, visualization, and well, you can display your videos. This is the secret sauce, what makes deep streams so popular and so efficient. It is called zero memory copies, and by saying that, we mean that once your data actually enters the GPU, it stays there for the whole pipeline, from the decoding to the final plugging. And by doing that, we eliminate the bottlenecks associated with copying the data from the GPU and CPU back and forth. So this is very useful. And this is an example application which I have created with DeepStream. So that's me in my home office, and I did it a while ago. So what I did here, I took the PeopleNet model and I retrained it using some publicly available data set for hand recognition. So I trained a hand detector here. And then from the NGC, I have downloaded a gesture recognition model. And without any further training, I took these two models. Well, the first model, of course, pre-trained, but the gesture recognition model, I didn't touch it at all. And I have deployed it using DeepStream. And there are two models, you can imagine, detector and a classifier. And it runs real time. It's very smooth and quick, and everything thanks to all the software products which I was using there. So here's a list of the resources I'd like to share with you. So the link to our Tower Toolkit, DeepStream SDK, TensorRT, Triton, NGC, and we also have our developer forums where you can ask different questions about our products. And finally, also Deep Learning Institute, where we provide you with some training materials. Very important that our GTC is coming soon. And again, we are joining forces with Microsoft here, and we are hosting, well, Microsoft is hosting the so-called watch party. The name of this watch party is Operationalize Large Model Training on Azure Machine Learning using Nvidia multi-node A100 GPUs to connect with the experts and get your questions answered. So this is really, well, your chance to come and talk about our technologies, and I'm pretty sure it's going to be fun. The dates for the GTC are September 19th, 22nd. You can find this session by scanning the QR code or looking it up in the session catalog. So to summarize my part of the talk, for efficient AI video analytics, you should consider like the whole end-to-end workflow. So when training, consider doing transfer learning, automatic mixed precision, multi-GPU training, data augmentation, and also applying the techniques like pruning and quantization. Then optimization step is crucial to make your models being high in throughput and low in latency. And for that, you can do techniques like layer fusion, kernel auto-tuning, dynamic tensor memory, and so on. And for that, we offer our TensorRT optimizing compiler. And finally, to deploy your models, you need to consider concurrent execution, zero memory copies, and integrated encoders and decoders. And for that, we provide you with tools like Triton Inference Server and also DeepStream SDK. Thank you very much.
Well, thank you. Thank you so much for this very inspiring talk, Katja and Gabriella. I certainly learned a lot today. Basically that you, as a data scientist, that you are magicians. You can do everything from DevOps to software engineering to designing. You basically do everything. So what is, because I am mixing up the the job descriptions between a data scientist and a data engineer all the time. Could you maybe easily explain what's the main difference between a data scientist and a data engineer?
Sure. So there's a lot of difference in there. In terms of data engineering, they focus really on the databases, the data around it. Those are also the people that we definitely need as a data scientist to succeed, because the better prep the data, the better we can also train the model. It's definitely a different, job and also things that you would need to learn in order for you to be successful in that role. As you already saw, data scientists can be quite broad, and it is only growing more and more into different routes. But data engineering is definitely different from data science. I'm also looking at Katja here, maybe to add some additional comments here.
Katja, do you have anything to add? Like, for instance, for our future aspiring data scientists, since the world is changing rapidly, you mentioned like quite a lot of products and a lot of tools as well, and there are quite some some schools, universities perhaps, who are not ready for this just yet. So, in order to become the next generation data scientist, what do you recommend that our next generation data scientists prep for? What should they learn? Katja, you want to take this one? Oh, we lost. Sorry, we lost the audio.
Oh.
Oh, good. Katja, you want
Can
me
you
to
hear me?
repeat the question? Did you hear me?
I could hear you, but can you hear me?
Yes, perfect. Thank you.
Okay, so to answer your question, I think it's crucial for students and aspiring data scientists to learn such fields as mathematics, linear algebra, statistics. This is still very required for understanding how AI and AI models work. And of course, you can do a lot. Like, there is a lot of materials available online. You can follow Microsoft or Nvidia. We have our blogs where we share a lot of information and useful tips and tricks. Like, for example, I shared in my talk today. At Nvidia, we have our Deep Learning Institute, where actually you can sign up for courses, and we have instructor-led trainings and also self-paced trainings, which you can attend and learn a lot about different aspects of the technology and AI.
Thank you. And so what can I do if I might need some help with your products? Do you have mentoring sessions, perhaps?
So sometimes we organize webinars, but also the best way, if you really need, if you really have some questions or you're stuck with development and deployment, go to our forum, which I have mentioned in one of the links, and ask the question there. The forum is monitored by our engineers, and they do their best in order to answer it as soon as possible.
Thank you.
Additional, and I think that is also elaborating a little bit on what Katja mentioned for the GTC. So Nvidia GTC is coming up with also, it's their developer conference. And we're doing quite some sessions also together with Nvidia, including the watch party in EMEA, where we deep dive also a little bit on how we trained these very large-scale Megatron Turing models, which are even larger than the GPT-3 model that has been released by OpenAI. We give some insights of how we train these type of models and what tips and tricks you can use also for that. So I would highly recommend to go to that watch party, because we elaborate also on these kind of topics in more specifics that allows you to understand a lot of the topics that Katja just mentioned, how they have been applied to that on the Azure platform.
On the Azure platform. Perfect.
Yes.
Thank you. So I think we have time for a final question. Is CUDA knowledge required to use these products?
It is good to have it, but it's not required. So with all these products, we strive at providing you with like an upper level of abstraction so that like, you can easily use these products. And some of these products, they are zero coding tools like Tower Toolkit. It doesn't require any programming. And with DeepStream, we also have our Graph Composer interface, which you can also use in order to eliminate any need of writing your code.
Amazing. Thank you. Thank you both so much for your time. I definitely learned a lot. Feel free to share the links and also to the event in our chat so that our audience can look them up and maybe even sign up for that. So thank you everyone for listening to our first session so far. I think we are ready to move on with our second session.
Yes, thank you. Thank you so much. So let's switch topics. That was extremely interesting. But now our next topic is the metaverse. And a lot is happening, of course, around the metaverse, virtual, augmented, and mixed reality. And our next speaker is Thomas Lewis, mixed reality principal developer advocate. At Microsoft. And I also hear a big fan of Nirvana. Is that correct? So Thomas will take us on a fast-paced tour of all those realities. Tell us about what Microsoft is doing in this space and why, and also take a look into the future. Welcome, Thomas.
Thank you, everybody. I appreciate being invited, and I just want to give a special shout out to the presentation beforehand. I lead one of our AI teams in developer relations at Microsoft, and I learned new things as well. So I think that there's a lot of things that you heard in the first part that also will be a part of this conversation as well. So I'm excited to be here. So let me go ahead and share my slides here for you. All right. Is there anything else before I start?
No, I think that's everything. Afterwards, we have a bit of time, like 10 minutes for some questions. We get questions through the YouTube chat, so please put your questions into the YouTube chat. We can ask Thomas after his talk. And well, I'm looking forward very much to your talk. So take it away. Thank you very much.
Okay, great. Thank you. Yeah, and I'm excited to answer any questions that folks may have, afterwards. And you can also reach out to me. It may not show up very well here, but I'm on Twitter. I'm Tommy Lee. And then if you want to reach out via LinkedIn, I'm at aka.ms/Thomas-Lewis-LinkedIn. And just for those who don't know who I am a spatial computing advocate, and I lead teams for our cloud advocacy group in developer relations at Microsoft. I have teams such as our spatial team, which we'll be talking a lot about today. I have a green computing team, a data team, and an AI and ML team as well. So we get to talk about a lot of great things that are here today, and as well as in the future. So I'm excited again to talk to you about these things. The agenda is fairly simple. First off, we're going to talk about what is mixed reality. There's a lot of different conversations around what is augmented reality, virtual reality. Do we call it extended reality? So we're going to talk about what we call mixed reality, which is hopefully all encompassing and can kind of help with the vernacular that we end up using. Then we're going to talk about what makes up the tech stack. So folks are quite interested in understanding, like, is it just the device itself? And what we're going to find out is that the typical device you put on your head is only just kind of one part of a larger ecosystem that we need to think about. And then, of course, what I probably most people are interested in is talking about the metaverse. And so I'm going to give you a sort of opinionated view of that. It's going to be a little more focused on how we can think about the metaverse and what makes up the metaverse as sort of this North Star that we are thinking about. So, first off, let's talk about mixed reality. Mixed reality is a term that's been around for a while, and basically, it is a blending of the physical and digital worlds. And so, typically, when we think of the virtual reality, we think of the digital world, right? Where we have a device where we're totally immersed. We don't see anything around us. Whereas on the opposite side of the spectrum, we have the actual physical world, and this is where augmented reality is placed. And so this is where I'm usually seeing holograms within the environment. So I would see them, for example, here in my office. And then we have this kind of spectrum of like what's more augmented versus what is more virtual. And so that's why we talk about mixed reality, because even though maybe at first, as augmented and virtual reality were coming to be, a lot of devices were kind of very much on one side or the other. We're starting to see where they actually are starting to kind of meld into this spectrum. So, for example, you've heard of MetaQuest probably. They have something called pass-through, which is it's typically a virtual reality device, but in some situations you can make it where it uses the outward-facing camera for you to see the real world around you, and then they can put in various again holograms or things like that, or 3D assets in the space that you're actually physically in. So if you're really wondering how this works, I'm just going to show you a simple example here. So here, for example, is a typical, office setup with a real person there. And as we begin to kind of move the dial from sort of very real to more virtuality, you can start to see that we add things, right? So you can see 2D applications here. You can see, a virtual pet or a virtual, dog, as you see. And then as we continue to kind of ratchet up the dial, we can then start to make changes to reality, right? So for example, instead of it being an actual person, it can be an avatar of that person and a reflection of what that person is doing, whether it's them moving their hands or moving around, as you can see here. And then as we move the virtuality all the way towards immersion, we can now do very interesting things. Like we can create, scenic landscapes, right? So if we say, hey, let's meet, but let's meet on the Mars on the planet Mars, we can actually go ahead and do that. So again, we have the ability to kind of take this and go from reality to virtuality as much as we want to, again, within the construct of being on the mixed reality spectrum. So you'll hear us talk about augmented reality, virtual reality, extended reality. All of these things are relatively similar, but we used, again, mixed reality as that way to kind of encapsulate that thinking of that spectrum. And we'll be talking about that spectrum quite a bit through different things we discuss. Now, we've been very fortunate. We've been working in this space for quite a while. So we've had a lot of user research that is done to figure out what makes the most sense for building experiences with mixed reality. And so here, for example, you can see remote expertise, getting information while you're in a situation, maybe you're on a factory floor, training and working together. Hopefully our next set of meetups at some point will be in this sort of virtual space where it will feel like I'm in your office, or that we're all together in a particular scenario or experience. And these are the ones that kind of come up over and over again. So if you're kind of trying to figure out like, well, when should I use mixed reality? These are probably the kind of opportunities that pop up the most. I would say the last one, Connect and Create, is probably more, I would say, on the frontier of what you'll start to see folks doing. But we've got some interesting folks who are thinking about these things. So, for example, there is a company called Spatial, for example, that does this kind of stuff where you can meet together in a room or in an experience, and you can interact and engage with each other as if we were all in the same room. But the question I always get is, okay, all of this AR, VR stuff, seems to be very hyped up. And aren't there already technology solutions that solve problems that people say AR and VR will solve? And in some cases, absolutely. So I want to make sure that I'm not hyping this up as like, oh, this is the greatest thing ever. There are, situations where, hey, this isn't going to be a good fit. The litmus test that I always use is, does the technology problem deal with people, places, and things? If you find that the problem space has all these three things combined, what you'll usually find is that spatial computing or building a mixed reality solution is probably going to be the right path for it. And so, we're starting to see, for example, smart buildings, right? Where we're looking at like, hey, how do people move around? What are the things that are in that smart building that we need to think about, right? And we even start to kind of like delve into IoT, right? Because we have all these sensors that are in these smart buildings, and we need to make sure that, hey, we can respond to them in a timely manner, or we can gather that data and do simulation. And we'll talk about that more, as we go forward in this presentation. So I'm showing you here the Microsoft mixed reality technology stack, but I think what you're going to find is regardless of what vendor or company you look at, they'll all have a kind of a similar thing here, right? Where they'll have the devices. And those devices are going to not just be, particular to that vendor, right? So for example, although yes, people are probably most familiar with a HoloLens device, we look at a lot of different devices as we build solutions in this space. So we're looking at mobile devices. So for example, we want people to be able to use their iPhone or their Android phone to be able to look at these amazing experiences. It might be a virtual reality device, or it might be an augmented reality device. And then we can start to think of other things too, right? Like, what about drones? Could drones be a possibility of a device that allows us to kind of balance between the physical and the digital world? And for us, like I said, we have sort of an open policy. So for us, we want to work on all devices. So even though you see a certain set of devices here, we also focus on making sure that we can our software solutions can work on things like the Meta Quest or on Magic Leap and things like that. And we consider those folks our friends. And we also too want to make sure that people can use what works best for them. So if it turns out that, hey, you want to use our device, but you would rather use a different set of software, we're okay with that, and vice versa as well. And I'll talk about that here in a little bit too. And so what we've done is we've actually, on sitting on top of kind of the devices stack, we also have a set of services that people can have. Again, we're not the only ones doing this. Our good friends at Qualcomm have built something called Snapdragon Spaces that have a lot of these kind of services built into it, in additional services. Also, too, if you've played Pokemon Go, the Niantic folks, they've now built a set of services that you can use again to do spatial type of experiences. And so again, doesn't have to be Microsoft. It can be just about anybody, or it could be a mix of those things. And we definitely want to be sure to support that. And then there's the applications that are built on top of that. And some of those are custom built, and some of those are part of our first party tools like Dynamics 365. And I'll actually show you an example of those. But again, this is the kind of a Microsoft centric view. That doesn't mean though that you can't have a lot of different other companies and the work that they're doing. I mean, there's a lot of great work that's happening in other places as well. So the HoloLens is probably the device that everyone is mostly familiar with. This is our augmented reality device. It's been around since, I want to say 2016. I think we announced in 2015, and then it was available. The first version was 2016, and it was a developer device when we first, released it. Because, like I said, it was something that took a lot of, time to value because you had to build a lot of things yourself. But I'll talk about some things that helped with that. And this has been a work for a long time. If you all are familiar with the Microsoft Connect, a lot of the things we learned on with the Microsoft Connect has found itself into the HoloLens 2 as well. And so, we think that that's very interesting and that the space continues to evolve, and we have a lot more room to grow there as well. Now, the question that I always get is, how do these things actually work? Because it feels like, hey, aren't you just kind of putting a little piece of glass up and you're just kind of like putting an image on there? No, these things are very complicated and complex. And so, for example, I'll explain how the HoloLens 2 sort of works at a high level, and then other devices may work a little bit differently. But for example, we use something called a MEMS laser display. And this isn't something that we came up with. MEMS laser displays have been around for a while, but this is different than kind of our original HoloLens, because our original HoloLens was done with LEDs, and we could go for another hour just talking about why lasers over LEDs, over what have you. But it's a MEMS laser display. And so what happens is we have 3 lasers that are RGB that allow us to create any color. And then basically what happens is we shoot the photons across a fast scan mirror and a slow scan mirror. So the fast scan is about 12,000 times per millisecond, I believe. The slow scan is a little slower than that. But basically what it does is it takes that photon and spreads it across the horizontal and vertical, creating a virtual display. And then the laser is actually projected onto the back of your eyes. And again, these are very safe lasers. You don't have to worry about damage to your eyes for sure. And then, of course, from there, you need to guide the waves of photons. And so you've probably heard the concept of waveguides. So we have to have the right set of lenses built into this. And this is very challenging, right? Because you need these lenses to guide things, but also there's not a lot of room for error. So for example, spacing between some of the lenses is the size of red blood cells, for example. So this isn't something that, again, you just kind of can put any kind of lens in and it just works. And that's why you sometimes can find these devices to be fairly expensive. And then finally, there's a depth sensor that is in addition to this, which is, again, comes from our work with the Connect. And what it does is it sends the photons out at speed of light and then times them as they come back. And that's how we get depth, right? That's how we know how far away something is because we shoot that photon, it bounces back, and then we kind of time that. And that tells us like, oh, this hologram or this item in the real world is this far away. And then we use AI, like you heard in the previous presentation, to actually fill the holes and deal with things like surface stillness for a spatial map that gets created. So we actually create a map, and you've probably seen this before, where a room is kind of all these polygons, right? And you can kind of make out that like, oh, that's a chair and that's a desk, but it's mostly just polygons. that's the spatial map that we're talking about. Again, this is super simplified. We can then get into things like thermals and how do we keep the device cool? How do we keep comfort? For folks, why did we use carbon a mask because we want to make sure that it dissipates and it works, and if you drop it, it gives a bit but still stays rigid. There's all kinds of things there, but I wanted just to give you some little bit of insight into, again, how the HoloLens works. And again, we've got quite a bit of work that we've done with it. So for example, if you want to use your a service for logging in, you can do that. We actually have eye tracking in there where we can use what we call Windows Hello. So what it does is it looks at your eyes and goes, oh, you're such and such, and then it will bring up your experiences for you. And if someone was to grab it and put it on, we would notice that there was a difference, and we would have to have them actually log into the device itself as well. So this device exists today. We keep iterating on it. So, it's not as if this is the, end all be all of HoloLens devices. You will definitely see things in the future. And from all the conversations that have been had, there's just going to be a lot of focus around things like immersion. So how do we make the field of view, bigger for folks? How do we create a more comfortable device? Because these devices, they weigh a lot. Your glasses, I think, are what, 5 to 10 grams, and these things can be 500 grams. So you're seeing that, like, it's exponentially heavier, but we're still working on things to make it more comfortable. And then, of course, that time to value, right? And a lot of that is happening through our open development that we have folks where they can use the tools that are open and open source that can make it easier for them to build out those experiences. So the HoloLens is an augmented reality device today. There's a lot of interesting virtual reality devices out there, and again, this is where you're immersed. You don't see the outside world unless you're doing something like pass-through. Probably the one that everyone knows the most of is MetaQuest. MetaQuest is one that's done by the folks at Meta. It's very affordable. It's a very approachable device, focused a lot on gaming and working into social experiences. This one in particular that I'm showing you is another device out there by the folks at HP. This is called the Reverb G2 Omnicept Edition. And this is a really interesting to folks who are looking to kind of really push the edges and do research. So you see, for example, it has a face camera added to it and heart rate sensors and eye tracking and things like that. And so you're starting to see that these virtual reality devices keep continuing to add more and more sensors and technology to them. And then if you're really looking at high end, I would take a look at Varjo, Varjo. Varjo is out of Helsinki, Finland, and they have a very high-end, high-end virtual reality device. And so if you're doing simulation work or some pretty intensive work, it's worth taking a look at. Now, their device, of course, is going to be much more costly than maybe like a MetaQuest. But for the kind of work that you may need to do or want to do, that would be something to take a look at. So Varjo, I'm a real big fan of them. And you can check them out at Varjo. And again, take a look at this HP as well if that's what you're interested in too. And so we have actually built something called a mixed reality toolkit because the devices themselves can only do so much. And then you need to kind of work through software through an SDK to do more than that. So here, for example, you're seeing things like, the object, as we saw here, the object manipulator. So this allows us to actually take a object or a hologram and move it around, right? Then we have things like bounding boxes that you saw up here. where when I get close to the device, I get these bounding objects that I can move things around. And then here, for example, hand menus, right? So I can bring up my hand and a menu shows up here. And then things like spatial awareness that you see here, where it understands that there's a wall here. And then you can see, for example, standard shaders that are added to that, as well. And by the way, like, MRTK is one of many reality toolkits that are out there. Like I mentioned before, our folks at Qualcomm have Snapdragon Spaces. And I would absolutely say, check out those folks and see what works best for you. Our MRTK is actually, we're on the 3rd version. There's a preview available that does a lot of the heavy lifting for you, because one of the challenges of working with in the space is the fact that it takes a little bit of, well, not a little bit, a lot of effort to get up and running quickly, because we're still kind of very new and early into this phase. Now, we have made a set of offerings through our cloud available to folks to use. So, for example, spatial anchors, where we can set an anchor in the real world, and you can come back to that anchor and it stays in the same place that it was before. Also to remote rendering. So, for example, 3D elements or 3D files can be fairly large, especially if you want more fidelity. And the problem is that when you're trying to like send, a big, large 3D file over a network, it can be really, timely to get that over there. So what a lot of people do is what we call decimation. And what they do is they kind of tear it down, and kind of, try to make it more efficient. But the challenge is sometimes it doesn't look as good, right? Or that it's low, it has a low poly look to it. So with Azure Remote Rendering, what we do is we do the rendering on the server so that you get 3D assets that are optimized, that still have the fidelity that you would expect. And we'll talk about Azure Digital Twins here in a little bit. And then with the cognitive services that you see here, you can build on top of ours, right? So if you, for example, we showed a demo of someone speaking in English to someone who understood Japanese, and there was that translation back and forth that was happening through cognitive services. And so there's, things like vision, language, knowledge search, and additional things that we continue to add to this. So you can kind of use the best of mixed reality and cognitive services together. Now, we also have first-party applications. One that you see here that is showing in the video is around remote assist. And so this is probably one of the biggest scenarios that people like to use HoloLens for. And so this allows remote experts for you as a person to reach out to an expert who can look and see what you're looking at, and then can annotate as well. So they can show you, hey, here's what you need to do. Here's where the problem may be at. So again, the great part of it is that you can solve problems in real time. You have information available to you without having to like pull out a manual or anything like that. And again, that you can do this anywhere that you want. So it can be out in the middle of a field if that's what you want, and you have connection, of course. The other big part of what we're seeing a lot of enterprise applications doing is around training of folks, especially what we call first line workers. So these are folks who are usually on the lines themselves. They're the first people that maybe a customer engages with. And instead of having very costly training and trainers and things like that, instead what we can do is we can give them the opportunity to see in real time as they are building things out. Then also too, we do have things like AltSpace VR. So you're starting to see a lot of folks who are kind of interested in this from the social aspect, which should make, which should make sense to everybody, right? Because, uh, you know, I remember when Twitter first came out and Instagram would come out, we'd always hear, why do I want to see what someone is eating, right? Because people were taking pictures. And what we didn't know was that that was kind of a social construct for us to talk and interact and engage with folks. And especially over the time of COVID, we were wanting to find other opportunities to be amongst others and have that immersion. Right, because the immersive part is probably the most interesting part of this. I've been a part of a lot of different meetups within AltSpace VR and other types. I've also done meetings just individually with people on my team and one-on-ones where they were, the avatar virtual representation of them was actually in my office. And I can promise you, it felt more immersive. It felt like the person was there. And I remember those meetings actually more than any of my other meetings that I've had. And I have a lot of meetings as a manager. So I think what you're going to start to see is this will continue to grow. And these are kind of our precursors to Metaverse. And again, we're going to talk about Metaverse here in a little bit. We also announced a little over a year ago Microsoft Mesh, and so this was our SDK and experiences that we're building to enable presence and shared experiences. So again, you're seeing here in this picture, there's a person who's there in real life. There's a person who is there as an avatar, and then on the right, this person is a real-time representation of a person that is somewhere else as well. And we call that holoportation if you're interested in that. But again, the good thing is that we feel the presence. Those folks feel like they're actually in the room. We can experience things together, so we can take a look at like the engine of something, and we can all kind of be looking at it in a different way, but we're all looking at the same thing, and we can edit and stuff like that, and everyone will see it. And that person again could be on in a HoloLens, or maybe they're on a mobile device. And so again, we want to make sure that when we build these experiences, that we allow for people to bring the devices that work, the best for them, or the devices they have access to. Microsoft Mesh is a little bit of everything. So it's part SDK, but there's also a Mesh app. So if you have a HoloLens laying around, which I don't know if many of you would, but if you do, we have the Microsoft Mesh application. And so it's a reference app for how these Mesh apps will act like. And Microsoft Mesh, again, is going to be a part of sort of the overall Metaverse story for Microsoft as well. Now, one of the things that we get a lot of feedback on our team is, well, HoloLens is great, and the folks like Magic Leap are doing really interesting things as well in augmented reality, but we don't have the budget, right? We can't assume that our folks can afford a multi-$1,000 device. Also, too, the challenge may be that a person has more of a web background than quote unquote a 3D background, right? So a lot of the folks who are in this space, they use Unity a lot or Unreal a lot, and they kind of do a lot of these 3D experiences. But what do you do for folks who aren't maybe going to have the devices and come from a web background? So what we have done is we've invested in our efforts around WebXR. And WebXR is a standard that's being built just like today the web is at the W3C around, hey, how do we build these engaging scenarios on the browser? And so we have built a tool or a JavaScript library called Babylon.js. There's other 3D JavaScript libraries. 3JS is probably very, very popular amongst most folks. There's also A-Frame. A-Frame is great for, especially if you're just starting to learn and you want to sort of treat 3D elements as a part of like an HTML element. So if you want to just declare a circle and that circle pops up in the browser, those are perfect. Babylon.js does a lot of that and a bit more. The way that we talk about it is that it's powerful, beautiful, simple, and open. Those are kind of the driving factors for Babylon.js. And again, this library is free. Totally web-based, open, and standards-based. So you don't have to pay anything. Even if you have the biggest instance of Babylon.js, it's still very free. You can do 2D and 3D work with it. There's no plugin needed, so you don't have to install a plugin for it to work in the browser, and it uses WebGL, and it works across all the various browsers as well. They try to build for backward compatibility so that if you're using an older version of Babylon.js, it will continue to work. It also has a full-featured game and rendering engine, so anything you need, like physics, particles, animations, you name it, it has that ability for you to build on top of that. And there's some games that have been built on top of Babylon.js. Also, Babylon.js is not just a web thing. It's also used in a lot of native apps. So there's kind of a native version of it that you can run. And some of our products actually use it. So for example, if you've ever used PowerPoint Online, a lot of that is built with Babylon.js. So it's showing up in a lot of different places, not just the web, but in native apps as well. There's a lot of great support as well too. This is a team that optimizes towards fixing bugs. So if bugs come through, they are prioritized very highly. So it's not one of those things where, hey, we send out a feature pack and then it's a year from when you may get your bugs fixed. This is something that sometimes they'll even prioritize the bug fixes over working on new features, which is not very usual for a lot of software developers. And so, yeah, I would just say it's a really great team. And it looks like we still have a little bit of time, so I can show you an example of some of these things that have been built with Babylon.js. So here, for example, at Stockholm University, they created a virtual campus using Babylon.js. So here, for example, I can learn more about the university facilities, and it takes me there. And then when I select it, it'll show me a bit more information. So here we can see some of the sustainability efforts of this particular building. And then, of course, we can take a look at pictures as well. So if someone is new to the campus, they can get some really nice fidelity pictures there. There's also videos and webcams. So if you want to take a look at the webcams in the facility, you can see those as well. So you can see real time what the traffic may look like on your way to the campus. Also, for example, golf, the golf tour in US, if you're interested in golf, you can take a look at what folks are doing. So I'm not the biggest golf person, so please bear with me. But here again, you can see a lot of the 3D development, and then over here we've added a little bit of video to it so someone can see how it worked out. We can fast forward and just kind of see where the pins dropped for it. And again, we can see the person actually trying to sink the putt, which it looks like they do. Perfect. So there's another example. So we can use it kind of in entertainment. Also, too, people are really starting to use this a lot within retail. There's I would have to find it, but there is research that shows that retailers and e-commerce that use 3D tend to make more revenue and more capturing of their audience by using this. And so here, for example, we can look at these different what we call sheds here in the States. We'll bring this one up. And here we can see a 3D version of it. We can actually look at it in a variety of ways. So if we want to see the top, the sides, what have you. We can actually go in, and if we decide, hey, we want to put in some extra glass, we can actually put the placement of it. So here I can add an opening for that. And so you can go in and just try to make this look exactly like you want. We're even starting to see folks where you're able to put together whatever it is that you're buying, and then actually look at it within your own yard or within your own home. And so, like I said, this has become a very interesting place to use in e-commerce. And then there's also just fun things here. This is more of a trivia, but if anyone can tell me what the name of this movie was, I'd be glad to give you kudos. I don't have any giveaways, but here we go. If you're not familiar, this was basically an old town, and I'm going to kind of turn around in here and let you see sort of another clue here. So I'm going to just kind of flip it around. And you can see we have this very interesting car that we can, we can actually go in and look at the details on the inside. And we can walk around that car. So for those of you who are not familiar, this is the old movie Back to the Future. And this was one of the very first prototypes that the Babylon.JS team built. But it's interesting because, like I said, you can see here, we can go in and change different things. So we can actually add a gamepad to this. So instead of using a mouse to go around, you can actually use a gamepad or like a virtual joystick. And then down here, you see this where we can actually click to switch to virtual reality. So if we had a virtual reality device on and we went to this website, it would show it where, instead of me using the mouse to move around or a gamepad or a joystick, instead I would just kind of look around. And so again, if you're wanting to build for, the mixed reality and you come from a web background, absolutely take a look at WebXR and Babylon.JS. But again, it doesn't have to be Babylon.JS. You can take a look at some of the other ones that are out there as well that work just as good. All right, so let's talk about the metaverse. I think everyone is hearing a lot about it, especially when Meta made their announcement that they would go from Facebook to Meta, and then also gave their vision of what the metaverse looks like. Now, the metaverse is not sort of a new concept. There was actually a book a while back called Snow Crash that talked about the metaverse, and there's been all kinds of conversations around it. And so, today you see folks like us, right, talking about the metaverse. So, for example, our CEO, when they asked what the metaverse is, he said it was the next phase of the evolution of the web or internet and the increasing digitization of people, places, and things. And again, that people, places, and things kind of come up again. And there's different things we need for the metaverse to work, and we'll talk about some others here. And we have tools and technologies that help as well. And I think everyone's going to come with, hey, what could we do today? Because we're still kind of working towards what the metaverse is going to be. Now, I personally have done a lot of research on metaverse and how people talk about it, and I'll be, just very open with you. I find 80% of what is out there isn't truly what I think of as the metaverse, because again, I think of the metaverse as a North Star for a much bigger thing that we're doing. But the definition that I use is around what Matthew Ball, who is a venture capitalist, I believe he's in the Silicon Valley, he defined the metaverse as what you see here, and I won't read everything, but he's been very thoughtful about what makes up the metaverse, right? So when people say, hey, isn't it just games? Like if I go to, a game and I play, isn't that the metaverse? And the answer is no, right? Because there's a lot of different things that need to be a part of the metaverse. And the other thing I like about him is he's what I call and I refer to myself as is a cautious optimistic. which means that we're optimistic about the future, but we also know that it's going to take a lot of things to get there. So number one, how do we deal with like persistence, right? So if I am in an experience and I lay something down in that experience, how do I make sure that it's going to be back there, right? When I come back, how do these worlds work together, right? How do I go from one world to the next? Also, too, that it should be in the real world and the virtual world. So a lot of times people think, oh, well, this is all gaming, right? Because a lot of the metaverse sort of aesthetic is always more of like an immersive experience like you would have in VR. And what we believe is that the metaverse will include being out and about, in the real world without these big, devices on. So I would say if you are interested in kind of a deeper dive into his definition of the metaverse, take a, just Google Bing Matthew Ball, the metaverse. He's got a lot of what he wrote online, so you can read it all online, or like I said, you can get this book. And I make no money for the book. I just think it's a really great book, and I think Matthew has probably the best uh, discussion of what the metaverse is. But let's talk about some other things. So one of the things you'll hear me say over and over again, and I know I get some flack sometimes for this, is I believe the metaverse is kind of a conceptual North Star. I don't believe that the metaverse exists today into kind of what we think that it can be. And so today when people say that like, hey, the metaverse is already here, I would always take that with, with a grain of salt, because that's probably not true. But with that said, for example, there are 14,000 augmented reality apps in the Apple Store today. And it's kind of interesting because people are talking about a device coming, at some point soon. But the reality is that they have folks who are building on their SDKs and toolkits today. The other thing when I kind of look at is something in the hype phase, which, we kind of are in the hype phase. But I also look at, is there job growth outside of tech? So for example, are all the jobs just at, Microsoft, Apple, Google, what have you, or, Magic Leap? But no, what we're starting to see is folks like Nike and Disney building out amazing experiences. In fact, Disney just put out a augmented experience via their streaming service. So if you're watching their streaming service, there's an application in there that allows you to kind of view the scenery within your living room. And that's kind of interesting. And I think we're going to see a lot of more cool stuff from folks like Disney and others. Also, not last quarter, but the quarter before, there's a lot of funding that is happening in this space as well. There's been pullback because of the recessionary pressures, but there's still a lot of investment there. So our folks like InReal, for example, have gotten investments. Magic Leap has gotten investments. And so from the devices perspective, there's still a lot of interest there. And there's a ton of interest in of course, solutions that are being built. So things like for the medical industry and things like that, you're going to see more and more funding going that way. The other good thing is the metaverse is not owned by any one vendor. So even though maybe Meta, or Facebook calls themselves Meta, it doesn't mean like they're the end all be all. There's a lot of different companies that are going to be working with the metaverse. And in fact, I find the metaverse concept to be something that is even beyond companies themselves. And of course, it's going to span the digital and physical world. So, I don't believe that we're all just going to be wearing these big devices on our head and walking around. And I'll talk about that in a second. It's always going to be persistent and always on, so we can always go back into it when we want to. But it's not something that we're going to like jack into, like oh, I'm now going to go metaverse, right? We're not going to think of it that way. And like the internet and web, it can be consumer or enterprise. Now, a lot of people ask me, hey, does that mean I have to learn Web3 and crypto and NFTs? Totally, you do not. That really has nothing to do to make something part of the metaverse. Those are tools. There's some good usage of those, not so good usage of those. There's value there, but what you don't have to do is to know all the Web3 crypto NFT stuff to be a part of the metaverse or start building for the metaverse. And so Microsoft is actually putting its foot in this in a kind of a thoughtful way. One is we are building what we call mesh for teams. And so this means that when you are in a meeting, you can represent yourself as an avatar, or you can represent yourself in a space with others as an avatar. And this is kind of the first steps into this world. And again, we have Mesh for Teams, and this is the work that we've been doing. Our friends at Meta, they're using something called, or they're building something called Horizon Workrooms. And so I think what you're in, like, oh, and I forgot, Spatial is a company that's been doing this for actually a while now. And so I think what you're going to see is that a lot of businesses are going to start building sort of like, hey, how do we connect at work, whether we're in meetings or whether we're in this immersive space? We've actually, there's been some internal builds. So people internally at Microsoft are using Mesh for Teams, and all of them have said that they've really liked it. And even people who really hadn't thought about, the metaverse or anything like that, they're even finding that it's valuable, for them. And the other good part is you get to represent yourself, right? And that's the thing that's great about avatars, is that not everyone wants to represent themselves in the same way. We talked about mesh earlier, and we talked about digital twins earlier as well. And so I just wanted to kind of say, like, digital twins is going to be a big part of what we do in mixed reality. There's a lot of folks who are building out digital twins now, where again, they can do something like a smart building with all of these sensors built in, and use something like a HoloLens to visualize what's going on there, as well as how do we manage that. So, for example, if there is a fire down in the bottom of a smart building, we don't want to wait until things are batched up and loaded and done at another at later during the day. We want that to be a real-time alarm that can happen, and then we can simulate things as well. And for example, there's a cool company that did some interesting things where they were wondering, like, their conference rooms were either totally booked or there was nobody in there. And so they actually used a digital twin and simulated a variety of things and found out kind of like what was the best usage. And so, for example, if someone only had 2 people in a meeting, they didn't put them in a big conference room. They would actually put them into a smaller conference room, or would say, hey, can you use this at a different time? And so digital twins and mixed reality, I think you're going to see a lot more interest there in how those two connect. And then just some predictions I have for the metaverse. I always like to be a person who is willing to make some predictions. I may get them right, I may get them wrong, but they're fun to talk about. So my first prediction is devices will augment, not replace. So it's kind of like the Apple Watch. Everyone kind of thought, oh, once we have the Apple Watch, we'll get rid of our phones. We won't need them anymore. And that's not true. People still have their phones today, and in addition to their Apple Watch. But will it be as successful? Absolutely. The Apple Watch is very much a success in the watch industry. But again, these are meant to augment, not to replace things. So when people say, hey, you won't need a computer, you'll just have a device, and you'll have like 50 screens on the wall. And I always question, why would you want 50 screens? There's no way you can pay attention to that. Also, the metaverse is going to be fairly normal especially for younger people. Today on TikTok and on Snapchat, young people are using all kinds of lenses and augmentations to them. So they can be a butterfly, right? They can have horns. They can have a crown of roses on their head. And they're not going to be saying to themselves, oh, I'm augmenting reality. They're most likely just going to say, hey, I'm just using this and I'm having fun. Also, glasses are going to be the consumer form factor of choice. Again, you could use devices like I have back here, but those aren't comfortable. They don't look fashionable at all. And so what you're probably going to see is a bit more of these kinds of things, where you have, sorry, I'm trying to get it to show up here. These are the Nreal glasses, and so they're much lightweight form factor. It uses the compute in its compute device, and so you're going to see a bit more of that. And most likely, people will be using their mobile mobile phones as that compute part of the device. But that's where we're headed. And again, the metaverse is going to basically evolve into something like we call the web, right? And again, it'll just be something that exists. And again, we don't know what things are going to happen, right? So when we do finally reach what we call the metaverse, I think what you're going to see is like there'll be different types of businesses, different types of experiences. We'll do things in different ways because instead of having to convert to 2D, which is what we have to do a lot because our cognitive biases around 3D, instead of having to go back and forth, we may learn things in 3D and we actually may be smarter about it and learn a lot faster and retain a whole lot more in that situation. I went over a lot, and again, this was a kind of a quick guided tour. I would absolutely love for you to check out our docs at ak.ms Mixed Reality Docs. We have a little bit of everything for everybody. So if you are a developer or a designer or you're interested in Microsoft Mesh, we have that information for you. Even if you're an IT admin. So for example, if 10 HoloLens devices land at your desk and someone says, hey, how are we going to manage these things? We actually have that information for you as well. So please check that out. And then again, feel free to reach out to me on Twitter. I'm Tommy Lee. On LinkedIn, you can go to aka.ms/Thomas Lewis LinkedIn. Yeah, take a look at the reality docs, mixed reality docs. And if you are interested, we do have a non-marketing newsletter. So it's about updates to documentation, different content that we have available for you all. You go to I Want MR, and this is where you'll get kind of the earliest news if you are a developer or a builder or a creator in this space. And so I just want to say thank you very much for your time. I really do. I really am excited about this space, and please reach out to me if you're doing something interesting or you have any questions. Please reach out to me on these places. I'll try my best to respond in a timely manner, depending on how busy I get. But I will respond. So thank you for your time.
Thank you so much, Thomas, for this really interesting talk on like how the HoloLens works and like the technologies available at this moment and your thoughts on the metaverse. Great talk. We are almost out of time, so I'll keep the questions like real short. One question, you showed us this example of holoportation, where another person is visible as like a point cloud avatar. And the question is this technology already available to consumers at this point, or will it be in the near future?
So it's not available yet. It's something that we continue to work on. As you can imagine, it takes a lot of effort. What we have seen is, for example, one way to do it is to take some Azure Connects, put 4 of them together, and then have it work in real time. That's going to be the hard part, right? Is because trying to do this in real time is very difficult and very bandwidth intensive. And so, yeah, so today that doesn't exist, but absolutely in the future it will, as bandwidth gets better and we can kind of optimize around real time. And that book I was talking about by Matthew Ball, he absolutely talks about that. Is one of the harder parts that we're all trying to figure out. And this isn't going to happen just because of Microsoft or one of our friends. It's going to be because the entire industry sees value. And that's why you probably hear a lot of people talking about 5G, because they're like, wow, with 5G, we can do a lot more interesting things like holoportation.
Well, thank you again. Thank you so much for this great talk. Thanks also to our other speakers. One more time. Thank you, the audience, for watching.
And we will be back on October the 18th for a hybrid event where we will learn more about the Microsoft Ignite announcements. See you there, and thank you for watching.
Goodbye.
Bye.
Thank you.